Good evening, sir. By the way, I'm Jeremy Kalihat. Then, I'm here to explain the task that you are given. First is the characteristic of the principal words of air masses and the cyclogenesis, formation, and cyclosis decoy of frontal system. Air masses and fronts. What characterizes air masses? What define fronts? Air masses is contain uniform temperature and humidity characteristic, and the fronts is boundaries between unlike air masses. Air masses have a fairly uniform temperature and moisture content in a horizontal direction but not uniform in vertical. Air masses are characterized by their temperature and humidity properties. The properties of air masses are determined by the underlying surface properties where they originate. Once formed, air masses migrate within the general circulation. Upon movement, air masses displace residual air over location, thus changing temperature and humidity characteristic. Further, the air masses themselves moderate from surface influences. Modification of CP air masses. Migration of CP air induce colder, drier condition over affected areas. As CP air migrate towards lower latitude and warm from beneath. As it warms, moisture capacity increase while stability decrease. Source regions. The areas of the globe where isthmuses from are called source regions. As source regions must have certain temperature and humidity properties that can remain fixed and substantial length of the time of the effect air masses above it. Air mass source regions occur only the high or low latitude, middle latitude are two variable. Classification of air masses. Air masses are classified according to the temperature and moisture characteristic, their source region, basis moisture, content, potential, dry and maritime moist. Based on temperature, tropical, warm polar, and maritime moist. Based on temperature, tropical, warm polar, cold, Arctic, extremely cold, and the naming convention for masses, a small letter C, M indicates the moist content followed by a capital letter T, P, and A to represent temperature. 5 types of air masses. First is the theoretically there should be 6 types of air masses, 2 moisture types and 3 times temperature types. But MA type maritime Arctic does not exist. CA continental Arctic. CP is the continental polar and the CT is continental tropical. And the MP is maritime polar, MT maritime tropical. Continental polar or CP air mass. Continental polar air masses from over large high latitude land masses such as northern Canada or Siberia. CP air masses are cold, extremely dry. Winter time, cooling over these land areas cause the atmosphere is to become very stable even inversion. The combination of dry and stable conditions ensure that few in any clouds form over a CP source region. Summer CP air masses are similar winter CP but much less extreme and remain at higher latitude. Continental Arctic CE or air masses. Continental Arctic CE air represents extremely cold and dry condition as due its temperature. It contains very little water and vapor. The boundary between CP and CA is the shallows 1 to 2 kilometer Arctic front or CA air masses can extend as far southward as the Canadian United States. Continental tropical or CT air masses. Mainly summertime phenomenon exclusive to the desert southwest of the US and modern Mexico. Characteristically hot and very dry, very unstoppable, or yet clear condition predominate due to a lack of water vapor. Thunderstorm may occur when moisture advection occur or when air is forced orographically. Maritime polar or MP air masses. Maritime polar air masses from over upper latitude oceanic regions and are cold and moist. MP air masses from over high latitude ocean as CP air masses move into from the interior of continents IC or CP MP to MP. Ocean add heat and moisture into dry and cold CP masses along the west coast of the US. MP air affects regions during winter and may be present before mid-latitude cyclones advised over the continent. Along the coast, MP air typically affect regions after cyclone passage as the MP air wraps around the area of low pressure. Maritime tropical or MT air masses form over low latitude ocean and such as very warm, humidity and stable. MT air masses from Atlantic and Gulf of Mexico of the primary source region for the eastern US. As air advex over the warm continent in summer, the high humidity and high heat occasionally combine to damage levels. Empty air masses have an enormous influence on the southwestern US, particularly in summer. Fronts separate air masses and bring about change in temperature and humidity as one air mass is replaced by another. There are four general types of fronts associated with mid-latitude cyclones with the name reflected of the advancing air mass. Cold front. Cold fronts form when a cold air displaces warm air, indicative of the heavy precipitation, events, rainfall, or snow combined with a rapid temperature drops. And with the rapid temperature drops, it is a steep front slope, typically 100 and moving faster up to 50 km per hour and 30 minutes per minute. Northwesterly winds behind cold front and southwesterly in ahead the front. Rather straight line views or cold fronts. Rather created when warm air replaces cold air, shallow, horizontal stratus clouds, and light precipitation. Frontal fogs may occur as falling raindrops evaporate in the color of air near the surface. Sleet and freezing rain may also form. Half the slope of cold fronts typically 1 to 200 degree, moving slower about 20 km per hour or 12 minutes per hour. Stationary fronts, when so unlike air masses, remain side by side with neither encroaching upon the other as stationary from exist. Fronts may slowly migrate and warmer air displace above the colder. Fronts looping over the cold air. Unclouded fronts. Occlusion, the warm is cut off from the surface by the meeting of the two fronts. Usually, a first-moving cold front catches a slow-moving warm front. O din nga. A cold type occlusion is thin half of the continent, whereas cold from associated with CP air meets a warm front with a MP air ahead. So, a warm type of occlusion western edge of continents where the cold front associated with MP air invades our area which colder CP air intended. Two other ways to produce included fronts. First is some inclusion from when the surface low elongates and moves away from the junction of the cold and warm fronts. Some occlusion occur when the intersection of the cold and warm fronts slides along the warm. Dry lines. Because humidity is important determinant of air density, air masses with similar temperature but strong humidity gradients will act fronts. Boundaries between dry and moisture air called dry lines. They frequently occur throughout Great Plains and are an important contributor to storm development. Mid-latitude cyclones. Life cycles of cyclones, cyclone structure, stirring of cyclones, scale motion of atmosphere. So, first is the mid-latitude cyclone form along boundaries separating polar air from warmer air to south. These cyclones are large-scale system that typically travels eastward over great distance and bring precipitation over wide areas, lasting a week more. Polar front theory by B. Jerknes, the founder of the Virgin School of the Meteorology, developed polar front theory during WWI to describe the formation, growth, and dissipation of mid-latitude cyclones. Life cycle of mid-latitude cyclones is cyclogenesis, mature cyclone, and occlusion. Cyclogenesis. Cyclogenesis typically begins along the polar front but may initiate elsewhere, such as in lee of mountains. Minor perturbations occur along the boundary separating colder polar easterlies from warmer westerlies, a low pressure area from, and due to the counterclockwise flow in its colder in migrates equatorward behind and developing cold front. Warmer and moves forwards along a developing warm front east of the system. Cloud precipitation occur in associate and with converging winds of the low pressures center and along the developing fronts. So that's all for the task 1. Let's go for the task 2. So describe associate weather elements of the condition below in the location in the ABCD. 22.1 pressure is in ahead of the warm front. Ang pressure niya is to start to fall steadily. Quiet cold starts to rise. Clouds have drops and thickness and cirrus or straits and none of first rain closest to front, sometimes snow on loading edge, and the temperature is in passage of the warm front. And temperature is continues to fall, continues to rise. Cloud base is low and thick, nimbus stratus bursts and becomes blustery with strongest continue and sometimes heavy rainfall. Then C is warm sector. Then iyahang cloud cover ani kay to steady, quite mild. Cloud may thin and break, remain steady, box slightly, and rain turns to diesel or stop. Then letter D, passage of the cold front. Passage of the cold front ang iyang kuan na kay wind speed and direction. Wind speed can start to rise, sudden drop, and clouds thicken sometimes with a large ammonite. Speed increase sometimes to gale force sharp bursts, and heavy rain sometimes with a hail, thunder, or sleet. Then cold sector. Cold sector is kuan yan ni precipitation yan ni kay kuan. Continues to rise, remains cold. Clouds thin with some cumulus with are squally showers. And that's all, sir. Thank you.